Okay, so for those of you following this many-part series, that copy went really well. All I did was I went down here, just go like this, Alt and Shift at the same time, hello, and copied it like this. I did a little better job of lining everything up on the left side, and it just popped right into place. Okay? All right. You can try that at home. You've been warned to save your work first. We're all good. I'm not going to tell you to save your work first. That should be built in. Okay, now, because we added 3 more floats, we have to come down here. We're still not going to enable that, but we just need to change the stride right here on all of our vertex array attribute pointer things. Okay. And then we are going to add the normal to these guys to light the position, text chord. Okay, normal attribute as opposed to abnormal. Okay, are you satisfied with that description? With that comment in my code? Okay, this is going to be place number 1. What's the size of it? The size is 3. There are 3 of them. GL float, GL false, whatever that means. The stride here is 8 times size of GL float. This one, the offset's going to be 6. So then the one previous is going to be offset of 3. Okay, are you happy with this? Then we just go GL enable vertex attrib array of 1. Sorry. I know. And then we unbind the VAO. Great. Okay, so we just added the normal. We added the stride for the other attrib pointers. We don't do anything with the normal yet. No. Did I say we did anything with the normal? No. But it's there. No, I'm going to run it and see if I messed everything up. Oh, what do you know? It still works. It still works. My goodness, it still works. I'm just amazed at that. Let's go inside a cube. I just want to hang out here for like a day or a day and a half or a month or 2. You know, if only there was pictures of Hawaii in here. All right, we'll do that next time. Okay, that's like super awesome. I can't believe this stuff is actually working right out of the box while I'm recording stuff. So, okay, what are we doing here? Oh, okay, great. This one's ready. So let's just go. Okay, good. So those 3 are uploading. Nice. Okay, a normal vector. Yes, we just took care of that. Thank you. Because I had to click on here. Okay, try to visualize the normals are indeed vectors perpendicular to the plane surface of the cube. A cube consists of 6 planes. So that's almost an airport. It's a small airport. Since we added extra to the vertex area, we should update the lighting's vertex shader. We should. Although, okay, just to be fair, I've already got that in my vertex shader. Wait, where did we go? Where are we at? So we've already got it. Position, normal, text chords. Okay, we've already got it in there. We are normal ready. We're ready to be normal, kids. Not going to happen. Okay. Note that the lamp object uses the same vertex array for its vertex data. It does? Wow, but the lamp shader has no use of the newly added normal vectors. We don't have to update the lamp shaders or attribute configurations, but we have to at least modify the vertex attribute pointers to reflect the new vertex array size. He's talking about the stride, which we updated. Didn't we update that in the stride? Yeah, right there. See the stride? All the strides. We're good. We only want to use the first 3 floats of each vertex and ignore the last 3 floats. Wait a minute. So we only need to update the stride parameter to 6 times the size of a float, and we're done. Okay. He's talking, of course, about not using the texture coordinates, which I'm using, so I'm adding 2 more floats. It may look inefficient using vertex data that is not completely used by the lamp shader, but the vertex data is already stored in the GPU's memory from the container object. Pardon me, so we don't have to store new data into the GPU's memory. This actually makes it more efficient compared to allocating a new VBO specifically for the lamp, putting in the GPU. Okay, so, all right, okay, that little green thing. Okay. All the lighting calculations are done in the fragment shader. Wow. So we need to forward the normal vectors from the vertex shader to the fragment shader. Let's do that. No, but I want to keep them here. Oh, so we have to put an out. You know what I'm saying? Out vector 3 normal. Wow. Out vector 3 normal. Cool. Out vector 3 normal. It's normal to out those vectors. Okay, main GL position projection normal equals a normal. Oh, normal equals. Okay, hold on. We better do the capital normal and follow protocol. So capital normal equals little normal. Yeah. All right, let's just call it O normal because it's out normal. Just because I want to. Okay. Because I want to. Okay, normal, O normal. So O normal equals normal. It gets passed through. This is where I'm talking about. It gets interpolated in the vertices. And I know. Okay. What's left to do here is declare the corresponding input variable in the fragment shader. Oh, that, there's a connection there. You got to make the connection, I guess. So in vector 3 normal. And then, wait, am I doing that right? Capital normal is the out vector. So the vertex shader, the out vector is O normal, right? So the in vector in the fragment shader needs to be O normal. There you go. There you go. Okay, we happy now? I think we'll be happy. Yay, yay. Calculating the diffuse color. Calculating. We now have the normal vector for each vertex, but we still need the light's position vector and the fragment's position vector. Since the light's position is just a single static variable, we can simply declare it as a uniform in the fragment shader. Ooh, uniform vector 3 light position. In the fragment shader, okay. So uniform vector 3 light position. Okay, did we do that? Light POS. Let's go back. Let's do it properly here. Light POS, okay, in the fragment shader. And then update the uniform in the game loop or outside, since it doesn't change. They're talking about in the init. We use the light position vector declared in the previous tutorial as the location of the light source. Lighting shader set vector 3. Yeah, it's using that fancy shader or lighting. Okay, so light position, which I declared as a global. They said global, I made it global. Tell me I didn't make it global. I made it global. I put global on there. It's global. The whole world. So I'm going to do it right here in my init. Okay? All right. Is everybody okay with that? I'm scared. What? Oh, what did you click, Jeff? What did you click? Close that down. I'm ashamed and humiliated. All right. Thank you. So lighting shader. So when the last thing we need is the actual fragment's position. We're going to do all the lighting calculations, words with the vertex, amount of measures and transformations. Okay, hold on. Transformations. I just want to look at the source code. I don't want to see the end result. Okay. Okay, so where are we at? Light positions right there. Show me the next one. Oh, he actually does do it inside the loop. Okay. So lighting shader, light position. So you have to use the lighting shader and then copy it over. Okay. Which in copying it over, we're not going to use this set vector 3 thing that he uses. No, we're going to do our get uniform location. And then we'll, okay, hold on. Lighting shader, use. I'm so confused now. I forgot what I was doing. One last thing. What were you doing? Okay. Here it is. Okay, so we're copying the light position into the uniform. Okay, all right. Oh my gosh, I'm so old. I'm so old. So light shader use. Then what am I doing? So the first thing you have to do darn it, I get uniform location. So let's go like this. Light loc equals GL get uniform location. Okay? Can we deal with that? No, we can't. It's impossible. What are these? Like, what is model? Oh, GL int. There you go. Okay. And then all we have to do is send the vector 3 up to the uniform. So we're going to go GL uniform vector 3. Is that 3FV? Like that? Okay, location, that's going to be what? It's going to be light LOC. Size count 1, and then the value. Isn't that going to be the light? Like that? No, that's not going to be it. Why not? I'm confused. GL uniform 3V. When all else fails, just Google it. GL uniform 3V. Oh, wait a minute. Is it 3F? It's supposed to be 3F? I don't know. Just 3F. I'm so confused. 3F. Location. Light LOC. Oh, and then the floats. But it's a vector. Alright. I'm going to figure this out off camera. We'll do another part to this. Stay tuned.